Hello everybody and welcome to my cell phone signal repeater booster Femtocell project. Okay, if we just scroll down here a minute, this is the basic concept. If I can just get that to zoom in a little bit. There we are. Right, so where I live, I get fairly poor 4G signal. I just about get it. If I were to hoist my phone, which is represented here, up a mast with a USB cable on it, I can actually get very good 4G reception. But when I'm actually in my house, 4G reception is poor or intermittent. So yeah, I'd like to resolve this problem, not just for myself but for other people as well. And to do that, I have created this this concept here, and I've proven at least part of it to work. I've actually proven this blue line here to work, so I've got that working. The way the whole system works, this is the base station here. This tower represents the base station, and it's interacting with my own outside aerial. It's a bit like a TV aerial, and it works in two directions. And I have a couple of two sets of bandpass filters, which enable the same aerial to be used for the base station transmit and base station receive. And again, I've got band pass filters on the other side, and I have an inside aerial interacting with my mobile phone in the same way. And in between I have amplifiers, just basic nice linear RF amplifiers cascaded together. And the project itself is split up into two halves. I've got, if we just look at my very untidy desk, I've got my analog circuits here, which many of which are actually working. So I've got different chips I've been messing about with. Yeah, and this side of the project is working, and over here I have a Lime SDR board, which represents the digital side of it. And most of the work is done by this little chip. This is what I'm interested in, this little chip here. So in theory, this chip can do everything that all these boards do. So it'd be really nice just to be able to do everything here. But in real life, it's not quite so easy because, well, for one, the Lime SDR itself is incredibly complicated to set up. If we look at the actual register settings here in Lime Suite, you've got all these incredible array of settings. I mean, you know, what's all this about? And here, so it takes quite a long time to understand all this stuff. There are simpler programs to use to interact with it, like this one here. You can actually use it with building blocks like GNU radio. And here I've created my own little radio circuit, and here I've created a little transmitter circuit. And what I did on this bit of software was to take my local radio and retransmit it using the Lime SDR 1 megahertz higher, which is quite a useful little test actually, and I've used it for several different applications within this project. So the project itself is documented on the Hackaday website, which you can access from the description in this YouTube video panel. So and at the moment it's represented by a load of diary entries. This is the last diary entry, and this just shows the aerial that I use. Look, the project now has basic functionality. That was on the 14th of May. So part of the trick was to use this type of aerial rather than whip aerials. And these are my analog boards. These are the ones that worked, and this is the one that hasn't worked yet, which I'm going to have another go at. Just keep on going. It will get there on that side of it. So right back on the 21st of March is where I started actually documenting this project as a diary. So there's my analog boards, and this is the board for the duplex filters. And yeah, one of the really nice things about the Lime SDR is that you can see the whole band 20 4G spectrum on one screen, which is quite pretty. These are the bandpass filters, and look how they've engraved them in the factory to tune them really accurately. And there's me soldering them together, a bit nerve-wracking. Thermometer, just in a little kitchen oven, with a stopwatch and a reflow profile. And here's testing the duplex filters, so it's quite important that you know that the filters are working, because if the filters aren't working then nothing's going to work. So there we are, look, we've got connections reversed halfway through the waterfall, and here we've got a nice blank space. The filter has actually filtered out all the base station TX in this zone, and conversely it's filtered out all the base station RX, which is basically my mobile phone. You can actually see these little blips which represent my mobile phone communicating. So I started to get some success on the 4th of April, just using the analog part of the circuit and using the Lime SDR to see what kind of response I got from that. And yeah, I got a response, but no response on my phone itself, so for some reason the signal wasn't getting through. So then in parallel I went to the Lime SDR and tried to use that as a transceiver, just by converting a local FM station, and got that to work sort of reasonably nicely. And yeah, I was using this Pophos software for quite a while, which is quite nice. If we look at that in more detail, it comes in the form of building blocks. So this area here is a FM radio in building blocks, and then what I did is I added a FM transmitter and transmitted it 1 megahertz higher for testing purposes. So that's quite nice, user-friendly software to use. And then I tried to use that as a fully functional Femtocell, and failed miserably. I don't know why. I think there's a limitation with this software itself. It's just not quite up for doing this particular task, and what I got was identical spectra in each channel, which is not what you want. You want them to look different. This is supposed to be a phone, not a base station. Never mind. Anyway, more tests looking at the insertion loss in the duplexes, and then there we go. I actually managed to get settings generated by Pophos into Lime Suite by scooping them, which was quite a result. Saves a lot of heartache and aggravation manipulating settings in this panel. So you can just get Pophos, those building blocks, to upload loads of settings into here. Saves loads of work. Okay, so going on the 10th of May, it's not quite such a long time ago, I actually managed to, for once and for all, to actually locate my own phone on band 20. It's quite difficult. It took me quite a few weeks to actually realise what a phone looks like. And here it is in Lime Suite. The Lime Suite has a display panel, and there's my phone. And here we are as an app on my phone, trying to see if my various gadgets, my two solutions, my analog and my digital solution, whether I was getting results. And here we are, the last refit, it's nothing. So a long time I spent not really getting much result on my phone itself. And then on the 14th of May I actually got some success, and part of it was switching out the normal whip antenna to use this plate antenna here. And this one worked a lot better. So I got my analog circuits to work, particularly this one, but not this one. So this one needs a lot more attention. I'm on the 3rd iteration of this circuit board now. Here's the design here. It's just on its way from China as we speak. And in the meantime, I'm back to looking at using the Lime SDR as a signal booster, and looking at the calibration settings. I'm wondering why with basic transmit I'm not getting any response on my phone. Again, there's a video there which looks at it in more detail. These videos and this can be accessed in the link on this YouTube video itself. It's all documented on Hackaday. So if we go back here, you can see the Hackaday website. There we go. That's my cell phone signal repeater booster Femtocell, and that's where I am at the moment. Thank you very much.